Hello there. Thanks for joining us. This is Space Nuts, where we talk astronomy and space science. My name is Andrew Dunkley. Great to have your company on this, the 600 millionth episode. Well, it's maybe not that many, but we've done quite a few. What is it? 643 we're up to. Blimey. All right. What are we talking about? We're talking about an old clapped-out telescope. Fred happens to be its patron. He's old and clapped out too. We're also going to look at a new black hole discovery, which was made after two black holes collided, and they recorded the loudest crash of gravitational waves ever. So what's it going to tell us? Also, China is going to upgrade its space station and launch a new space telescope, and a star that got close to our sun may have caused a bit of a disturbance in the force. We'll tell you all about it on this episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And he's back again, as always. It's Professor Fred Watson, astronomer at large. Hello, Fred.
Hello, Andrew. Hello. Thank you for that nice introduction. It's nice to hear a welcome like that.
I know I only said it a few seconds ago, but I forgot what I said. And then it dawned on me that I'd actually insulted you. Yes.
Oh,
yes.
Forget about that. Yeah. No, that's all right.
That's all right.
You're
got
right.
me last week.
I am old and clapped out. There's no question about that.
Aren't we all?
Yes.
Aren't we all? Now, before we get into today's stories, the old clapped-out telescope I referred to is actually a wonderful device that I've actually seen in person when we were down in Melbourne a few years ago. It's the Melbourne Telescope, dates back to 1869, and you're its patron because you were there when they put the first screw in it. I got you again.
Actually, so the link and the reason why there's a number of reasons why this telescope is very close to my heart. One is that I was still at school when I found a picture of it in Henry King's History of the Telescope, a very famous book on the history of telescopes, published, I think, in 1955. I had a copy of that in the school library, and there's this telescope there, the Great Melbourne Telescope, and I thought, that is a telescope. That's what I want. That.
It just looks like
it does.
You'd expect one to look, doesn't it?
You can tell it's a telescope. It's got, with decorative bits like the lattice-work tube, which is very unusual, almost unique. Anyway, that was my first encounter with it, and has sort of followed up as much as I could. I didn't realise that by then it was actually in Canberra at Mount Stromlo. It had been refurbished, having left Melbourne in 1944. But 100 years exactly after work started on the manufacture of that telescope in 1867, 100 years later, I joined the company that built it.
Oh.
So it was its 20th century equivalent. It was Howard Grubb Dublin when the telescope was built. By the time I got there, it was Sir Howard Grubb Parsons and Company Limited. But it was basically the same company, amalgamated in 1926 with the Parsons Company. So I continued my kinship with that telescope, and of course, when I came to Australia, was interested to see it at Stromlo. Then in 2003. The Stromlo Observatory had that terrible bushfire that went through, destroyed all the heritage buildings, including the one that that telescope sat in, and basically melted melted the dome onto the telescope. The dome was aluminium, and the telescope was wrecked. Its mirror was smashed, and all the rest of it. So I wrote a book on the history of telescopes, which was published, I think, just after that fire, because I wrote at the end, I had a whole chapter on this telescope, and I wrote something to the effect that the best we could hope to see would be for it to be a static exhibit in a museum, just the remnants. But
Which
I was wrong.
was for a while.
Well, it
Wasn't
wasn't. No, it stayed put in Stromlo, and it was 5 years after the fire, 2008, when this consortium of Museums Victoria, the Astronomical Society of Victoria, Royal Botanic Gardens Melbourne, because that's where it started its career.
Yeah.
And the I think the Bureau of Meteorology were involved as well, and they got together a plan to basically restore it, so I did play a role in that. In 2015, we actually held a workshop which I chaired, which was about how you could update the optics of the telescope, because the mechanical stuff could be refurbished, but the optics were a different matter, and a sort of optical prescription was drawn up. Now those optics are still in the process of being manufactured, but the telescope itself is now essentially mechanically complete. It is as complete as it was when it was built, and the work that's been done, more than 100 volunteers and staff from Museums Victoria and the Astronomical Society of Victoria, it's well over 100 have worked on it. And so last week there was a little party to celebrate that, and some of the museum's dignitaries said a few words. I said a few words. The chap who's been leading the project, Simon Brink, over the last few years, he said a few words. He's actually coming to lunch with us on Saturday.
Oh, lovely!
Even though he's in Melbourne, he's coming up, which is nice. So we had a celebration. So, and to be honest, what they've done is nothing short of miraculous, because there weren't any diagrams of all the bits and pieces of this telescope. There were engineering diagrams of the thing complete. They were published in a journal, but the individual parts, and probably thousands of components, screws, washers, pulleys, cogwheels of various different sized, all of that. No idea what they look like. And by scouring photographs of the telescope from many sources and working out things like the numbers of teeth you need on a cogwheel to make the things work properly, they've done a great job with all that. And now it's basically in perfect working order, except it doesn't have its main mirror yet. That's being fabricated. It's at the moment still at Science Works, which is the Science Museum in Victoria, and it's a static exhibit.
Which is worth a visit, especially with the kids.
Yeah, it's a great place to go. And anybody who does go to Melbourne and sees Science Works, definitely have a look at the Great Melbourne Telescope. The hope is that one day it will be in its original building, which still exists in the Royal Botanic Gardens. But there's quite a bit of work needs to be done to make that OH&S satisfactory for 2026 or whenever it happens, compared with the the health and safety regulations in 1869 when people came and went, just had a look through the telescope. That's the idea, that it will eventually be a working telescope for the public, for people to come and look through.
Wonderful. And if you can't get down to see it in Melbourne, just do a search for the Melbourne Telescope online and have a look at it, and you'll know what we're talking about. The lattice work is just beautiful. It is a glorious piece of equipment. And I stumbled across it. I didn't even know it was at Science Works when we went there, and we just went for a wander and found it, and I went, Fred will love this. And then it turns out you were the patron. So
yes, that's right.
Yeah.
It's quite staggering. It's how big it is, isn't it? When you,
it blows your mind.
Yes,
you just stand there in awe.
Big telescope. It was the biggest fully steerable telescope in the world at the time when it was built. It wasn't the biggest, but it was the biggest telescope in the world, but it wasn't far off.
Yeah, as a good friend of mine often says, it's a great piece of kit.
It was a great piece of kit, and hopefully it will be again one day. Yeah.
Fingers crossed. All right. Moving on, we're talking black holes. Very unusual. We don't usually talk about things like this, but this is an interesting one because they've made it a bit of a discovery. They've recorded the loudest crash of gravitational waves ever heard, and it was because of two black holes that decided to play billiards with each other, and boom. But it's what they've discovered in the aftermath of all this that's getting interesting.
Yes, it is. Gravitational waves from colliding objects have been detectable by humans since 2015. with the LIGO Laser Interferometer Gravitational Wave Observatory in America, and that now works with Virgo, which is an Italian gravitational wave observatory, and CAGRA, which is the Kamioka Gravitational Wave Detector in Japan. So those three telescopes work together to pick up the vibrations of space, which are transmitted from very distant collisions usually. And it's usually neutron stars and black holes, with collisions between either neutron stars and neutron stars, or black holes and black holes, or neutron stars and black holes. Those all produce gravitational wave signals that are actually in the frequency range detectable by these telescopes, because that's a key part of it. The amount of energy that's involved tells you what the frequency of the gravitational waves is going to be. And as we've noted before, Andrew, it's curious that the gravitational waves that these telescopes are sensitive to are actually in the audio frequency regime. They're basically, if you just amplified them, you would have an audio signal, and that's basically what they do, except they're doing it in a very much more sophisticated way. The amount of shaking of space that they can detect is absolutely infinitesimal, but these things are sensitive enough that they can measure a distance that is 1,000th, I think it's a 10,000th actually, of the diameter of a proton. That's the accuracy with which they can measure the distance between two mirrors, which is how you do all this sort of thing. So that's the backstory. The up story, the forward story, is that an object, or you don't have an object, you have a gravitational wave signal. It rejoices in the name of GW 250114. That tells you that it was picked up in January 2025. That's where the 25011 comes from. And it basically, on analysis, has been detected to be a collision between two black holes, each of which had around 32 times the mass of the sun. And so they collided, and that set the gravitational waves on their way, because it basically disturbed space. It rippled space. So what's happened is, and this, as you mentioned at the beginning, is the loudest gravitational wave signal that's been detected, or that's certainly the most intense, the highest amplitude one.
Yeah.
So what has happened is that researchers have analysed the audio signal, and they've found in it basically that it's been described as a feature, which is something called a direct wave. It's a component of the signal, and it's a direct wave that's been seen before, but nobody's worked out what it is. But apparently it is a feature that essentially, in the gravitational wave structure that comes from this event, you can tell this direct wave is to do with the event horizon of the combined black holes. So you've got two black holes, each of which has got its own event horizon. They're spinning around one another, getting ever closer, as we've seen that sort of thing before, and the frequency goes up of the gravitational waves. And then suddenly it all stops because that they've collided and there's no more accelerations, which is what you need to set up gravitational waves. But at that point, the two event horizons merge. Now, a recap on event horizons, that's the point of no return, basically. It's the distance from the black hole where the escape velocity is more than the speed of light. And so nothing can escape from within the event horizon. And in particular, light can't escape. So the event horizon is black. It's a sphere around the black hole through which you can't see because nothing escapes, including light. So that is what the event horizon is. In a sense, it's imaginary, Andrew. You know, it's not a real surface. It's an imaginary surface because it's just the boundary between what's visible and what's not not visible.
Yeah.
Now, we know when black holes collide, I don't know that much about the details of these things, but there is a period immediately after they've merged, which is called the ring down. And it's a time when they sort of consolidate as one black hole. And that means their event horizons also consolidate. And I think this direct wave that has been detected is basically an artifact of that ring down. And so what I guess is perhaps the takeaway message from this work is not that we've learned something miraculous and new about the event horizon, but that we've learned that there might be a way of, in future gravitational wave events, might be a way of analysing these direct waves to give us more information on the black hole event horizon. Because at the moment, we don't know much about it. We've seen them in the telescopes, the observations from the Event Horizon Telescope, that amalgam of many radio telescopes, an Earth-sized array which has been used to look at the black holes in the centre of our own galaxy and in M57, I think it was, with a fairly high degree of precision. What we've seen is the black shadow of the event horizon. But perhaps with these gravitational waves, these direct waves, there might be a way of teasing out even more detail from these distant and highly enigmatic objects.
Yes, indeed. And another interesting thing that comes out of this story is that that they're suggesting the measurements that they've made could be a step towards future tests of general relativity.
Quite
using
so,
direct
yes.
waves. So, there's all sorts of potential by the sound of it.
That's right. Yeah, I mean, exactly. And of course, this is one of the holy grails of science generally, actually, certainly physics, to find chinks in general relativity, because at the moment, it behaves exactly as predicted. Everything that we've seen in the universe follows the rules and regulations of general relativity in a perfect way. So maybe direct waves will, as you said, give us a way of testing general relativity. If we find things that don't work in general relativity, then that could be an opening into new physics, which is certainly a hot topic at the moment.
Indeed it is. Everyone, including Einstein, thinks something's wrong with it. They just can't find anything at the moment. Yes. It keeps coming up aces every time they test it.
Yeah, they think something's wrong with it because it doesn't sit with quantum mechanics. The two are incompatible, and they both work perfectly well, but they're incompatible.
Weird, isn't it?
Yes, that's very weird, yeah.
The other thing that I find fascinating about this story is that from something as simple as a gravitational wave, they're able to break it down and find information that is really just, you can't see any of this. It's all just data, isn't it?
Yeah, that's correct. That's right. But the physics is well understood because general relativity is such a reliable tool for people to use to analyse these things. That's how we can make these statements about it. And yes, if we can find flaws with general relativity, it will be very exciting.
Indeed it will, and you can read all about it at the space.com website. They published their research in the journal Nature. This is Space Nuts with Andrew Dunkley and Professor Fred Watson. Let's take a short break from the show to tell you about our sponsor, NordVPN. Let's talk about your online security. Now, I can tell you from personal experience, last year when Judy and I were overseas, we ran into a bit of a frustrating issue. There were certain apps we simply couldn't use without a VPN connection, things like our banking apps. They wouldn't load, and even a sports app I rely on wouldn't let me watch games back home because of geofencing and things like that. So with NordVPN, I was able to watch football back home while crossing the Atlantic Ocean. It was pretty weird, but it worked. And NordVPN is the best in the business. With NordVPN, you can securely connect to servers all around the world, which means your apps think you're right back home, even when you're not. It also encrypts your internet traffic, hides your IP address, and keeps your personal data safe from hackers and trackers and anybody else who's trying to get at you online. And this can happen in public Wi-Fi situations, in hotels, airports, cafes, anywhere like that. The best part, it's fast. Thousands of servers globally, and their NordLynx technology allows you to run seamlessly. No slowing down. It is brilliant. Right now, you can grab the special Space Nuts deal through this URL, nordvpn.com/spacenuts. You'll get 4 extra months free plus a 30-day money-back guarantee. So there's absolutely no risk if you want to give it a go. That's nordvpn.com/spacenuts. Stay safe online with our sponsor, NordVPN.
I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the earth.
Space Nuts.
Now, Fred, we turn our attention towards China. Of course, they've got a very active space station in operation at the moment. The latest news, though, is that they intend to make it bigger. And at the same time, they're going to put a new space telescope into orbit as well. So they're really going ahead in leaps and bounds, aren't they?
They are, yes. It's, this is part of the Chinese. It's not the China National Space Agency. I think it's that they've got a separate space agency for human spaceflight, and that's the organization that operates the Tiangong space station, which has been up there since 2021, I think, was when we started seeing it being assembled. It was assembled in a very similar manner to the International Space Station by building sort of modules that you can stick together like Lego up once these modules are in orbit.
Yeah,
and at the moment
it's the China National Space Administration, which handles the programs, and the China Manned Space Agency, which oversees human spaceflight.
That's right. I knew there were two organizations involved. Thank you for that.
That's all right.
At the moment, the Tiangong consists of 3 modules, and they're arranged in a sort of T shape, with three end points of the modules, if you like, coming together in a sort of vestibule where you can tunnel your way from one to the other with these basically entry and exit hatches. That is the way things work on the International Space Station as well. But as you've said, what they're now planning to do is to add 3 more modules. And the reason they want to do that is because they want to do more research up there and make more frequent crew and cargo changes. So they're actually... I think the way to deal with that is to make the space station bigger. And so it's going to be what they're calling a double T shape, which I think is probably an H shape, if I can put it that way.
Well, that's it would turn into that, wouldn't it?
You'd expect so. Yes, that's right. Unless they do something clever, like turn one of the T's round at right angles to the other one. Anyway, we don't know what's going to happen there, but there is a new multi-purpose module and 2 new experimental modules that are planned to essentially, allow Chinese space exploration in low Earth orbit to continue and be extended. We understand from some of the researchers in China that it's always been an expectation that this would take place, that there'd be this extension. And what it will do in terms of the mass of the space station is take it up from its current 90 tons up to 180 tons or thereabouts. And as a yardstick, if I remember rightly, and you might be able to correct me here, Andrew, but I think the International Space Station is about 400 tons in terms of its mass. I think that is the case. So that's the plan. And alongside that, as you've already mentioned, Andrew, is the idea of a new space observatory, an optical telescope, quite similar in some ways to the Hubble Space Telescope, a slightly smaller mirror, 2 meters rather than 2.3 meters. And also with a much wider field of view. The Hubble has quite a narrow field of view. And in fact, the Nancy Grace Roman telescope, which is also very similar to the Hubble, will have a much wider field of view than Hubble. That's being launched later this year, I hope. This Chinese telescope, which has a name, Shuntian, I think is probably how it's pronounced in my poor Chinese, poor Mandarin, poor Chinese. It's got a much bigger field of view and will actually give new surveys to Chinese astronomers. We'll see a lot more information about the universe coming from this telescope. So the more telescopes you've got on the universe, the better. And Shuntian will be one of those features when it is launched and actually commissioned that will, we hope, really bring new insights into our knowledge of space.
Yeah, apparently its field of view is going to be massive compared to Hubble, at 300 times.
Correct. Yes, that's right. So it's a wide-angle telescope rather than the sort of pinpoint view of the Hubble.
Yeah, quite incredible. You were right about the International Space Station. 419,700 kilograms is its mass, or say 420 tons. Yes, tons. Indeed. The other interesting thing that China's working on is a new delivery system for they call them taikonauts, don't they?
Yes, they do.
Yeah. They want to develop a rocket system that will send 7-Up at a time.
Yes, yeah.
Sponsored
Which I think
by 7-Up. No, I'm joking. But that's what they're looking at doing. At the moment, they can only send up 3 at a time.
Yes. So the Chinese orbital vehicle for getting astronauts up, taikonauts up there, and I'm ashamed that I can't remember what it's called. Is it Shenzhou? I can't remember. But that is basically an adaptation of the old Soyuz Russian spacecraft, which are still in service in the International Space Station, developed in the 1960s, a 3-person module. I think I'm right in saying that the Crew Dragon can take up to 7 astronauts as well.
Interesting.
So,
Shenzhou,
yeah,
is the system they're using at the moment.
Right.
You did.
Yes, so that will go from 3 to 7. It's understandable, if you want to keep the crews coming and going. I think this is a really important development because, if nothing else, it's going to, I think, spur the private sector on to pick up the baton of what you might call Western International Space Stations, or the Western International Space Station, because that's scheduled at the moment to be decommissioned in 2030. That might change, but it's a possibility that we will lose the ISS in 2030. And we've seen problems with the leakage that we had in one of the modules a couple of weeks ago, where the crew was evacuated, not evacuated, but moved. The American crew, the NASA end of the spacecraft, were moved into a Crew Dragon capsule to just be certain that nothing untoward was going to happen if there was a catastrophic leak. When the Roscosmos cosmonauts, they were actually trying to fix the leak. They moved the other crew into the Crew Dragon capsule for safety.
Yeah. In terms of replacing the ISS, there are no firm plans at the moment, but they're kind of thinking about. I think you mentioned it, the commercial sector getting involved.
Yes.
Yeah. So and that's probably logical. I'm pretty sure that Elon would be pretty keen to put a space station into orbit, and a few others probably. There's plenty of people around with megabucks to do it.
Yes, that's right. But you might have to think carefully about whether you take over the old tired and quite dodgy old International Space Station or whether you build something new. And of course, the technology's moved on enormously since the 1990s when that was put together. It's been continuously occupied since 2000. That's 26 years of tenants coming and going. It's probably taken a fair beating inside.
Yeah, I'm sure they've had a few parties. Yeah, no doubt about it. If you want to read all about China's plans, you can do that at space.com. This is Space Nuts with Andrew Dunkley and Professor Fred Watson.
Space Nuts.
Our final story, Fred, takes us close to home, and this is really quite a fascinating story because it talks about a star, not our sun, another star that got up close and personal with our particular sun a little while ago. But the effects of that interaction seem to still exist, which is very odd.
Yeah. Well, that's right. Yes, it is. It's an interesting story. It covers, two quite different bits of astronomy here that come together to sort of work out what was going on. So this star in question, it's got the glorious name of HD 7977. HD stands for Henry Draper. It's one of the early star catalogues from the 19th century, I think, the Henry Draper catalogue. And it's a relatively near star. Similar to the Sun, it's currently in the constellation of Cassiopeia, which is one of my favourite northern constellations, actually. It's one that we don't see from down here in Australia. So how do we know that HD 7977 had a near miss with our solar system? And the answer is with the Gaia mission. So Gaia is a spacecraft. It sits at the Sun-Earth L2 point. That's the Lagrange point on the opposite side of the Earth from the Sun. It's been working for, I think, certainly more than a decade. And what it's done is measured star positions with absolutely exquisite precision. You're talking about, I think it's sort of some accuracies in the region of 100 millionths of an arc second. These are phenomenal accuracies. And an arc second, of course, is 1/3600th of a degree, the size of here in Australia, a $1 coin held up at 5 kilometres. It's a tiny angle. Yeah. But this thing's measuring millionths of that, basically, or 100 millionths. And what that does is it allows you, if you make these measurements at different times, it allows you to plot the motions of stars, not just in our own galaxy and in our own neighborhood, but also in the two Magellanic Clouds, the two nearest neighbor dwarf galaxies, the big ones, large and small Magellanic Clouds, 165 and 200,000 light years away, respectively. Those you can detect the motions of stars in those galaxies, and even in the Andromeda Galaxy, about 2.5 million light years away, you can see evidence of what we call lateral motion on the sky, the sideways motion of things. And if you can measure the radial velocity, that's the velocity along the line of sight, which is actually much easier. If you can do that as well, you've got the three-dimensional motion of objects in space. And that is how it's HD 7977 was picked up as having passed close to the Sun about 2.5 million years ago, as both these stars, the Sun and HD 7977, as they both orbit around the centre of our galaxy. We still don't know exactly how close. The data from Gaia suggests it was between 4,000 and 25,000 astronomical units. And as we've mentioned before, an astronomical unit is the distance between the Earth and the Sun. A convenient measure, it is 150 million kilometres. They may have... that we might be able to tie that close approach down, though, by other methods. And the methods in question have been employed by some scientists at the University of Bordeaux. And basically what they have done is looked not at Gaia data to try and refine this sort of look back in time as to when these two stars were close together. They've looked at long period comets that come in from the very furthest reaches of the solar system, where we think there is a reservoir of comets. We call it the Oort cloud. And it turns out that if you look at long period comets, which have been measured, over the past 100 years, I guess, then you get an idea of the distribution of their orbits. And basically, there's a quote here from one of the authors of the paper that we're talking about, who says the distribution of comet orbits suggests we are living through an unusual time where HD 7977 has dominated the generation of new comets, and not the larger gravitational field of the Milky Way as it usually would. This would also mean we're living through the late stages of a pretty rare and powerful comet shower. And so what they've done is made computer simulations of how comet orbits might behave as a result of being tipped out of the Oort cloud by the passage of this star HD 7977. They're kicked out the Oort cloud and heading towards the sun. They've measured basically the details of 112 long-period comets. Actually, they've chosen ones that have only been observed in recent years, since 1989, because that's when we could detect comets coming from any part of the sky. If you only limit yourself to one part of the sky, then you've got as visible, for example, by a single observatory, or even as visible by the Northern Hemisphere observatories. You're missing half the objects that you want to see, and since what you're doing is looking at the statistical distribution of these things, you can't afford to eliminate things that way. It's what would be called a selection effect. So, yes, these long-period comets, they've got very elongated orbits, and the suggestion is that the distribution of those orbits in relation to the direction that we know HD 7977 went through the solar system or went close to the solar system, that's why they believe that the two events, the close passage of 7977 tipped up the comets and caused a lot more of these comets to come in. And if you accept their hypothesis, then what it does is ties down rather better the distance that we estimate HD 7977 approached the sun at, somewhere between 6,000 and 10,000 astronomical units, a tighter window compared with the 4,000 to 25,000 astronomical units that Gaia suggests.
Yes.
So it's a nice tightening up of our understanding of this hypothesized but probably real event 2.5 million years ago.
And just to give people a bit of an idea of the distance, so somewhere between 6,000 and 10,000 AU is where HD 7977 kind of grazed our solar system.
Yes, yeah.
Voyager 1 is 170 AU from Earth. So we're talking a fair way out.
It's a long way off, that's right.
You're talking probably getting into the vicinity of the Oort cloud, which makes sense given what they're hypothesizing in this paper.
Exactly right. So a star passing nearby the Oort cloud would definitely upset it and send stuff in towards the inner solar system.
Yes.
It's actually, it's a theory that that general mechanism was proposed by colleagues of mine in the Royal Observatory in Edinburgh, Victor Klube and Bill Napier, back in the late 1970s. The idea that they were suggesting it might have needed a bit more mass than a single star to disturb the Oort cloud, and they suggested the nearby passage of something called a giant molecular cloud, a kind of stellar birthplace. If one of those goes past the solar system, they were inferring that it would disturb the Oort cloud to the extent that you would get bombardment of the inner solar system by comets, and that might be visible in the geological record on Earth. That was their principal line of attack. Really very interesting science. So this is not a new idea, but this is new research that suggests that perhaps we can learn more by pursuing it.
Indeed, yes. The paper, by the way, has been accepted by the Planetary Science Journal and is available at the moment on the archive preprint server. You can also read about it at phys.org, phys.org. Fred, that brings us to the end of the show. Thank you so much.
Well, that went very quickly. What a good time we had.
We did indeed, yes. We'll catch you on the next one.
Sounds great. Thank you very much.
Professor Fred Watson, astronomer at large. And don't forget, between episodes, to jump on our website and have a look around, spacenutspodcast.com. You can click on the AMA button and send us messages, even if you want to send us a joke. We don't mind. We love jokes. Or you can send us a question, or you can comment on a discussion point, whatever you like. Just don't forget to tell us who you are or where you're from. You can send text and audio questions. And while you're there, have a look around, check out the shop, check out the ways you can become a supporter or sign up for the Astronomy Daily news feed. You can do all of that on our website. And thanks to Hugh in the studio, who couldn't be with us today because he saw a passing star and chased her down for an autograph. And from me, Andrew Dunkley, thanks for your company. We'll see you on the next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.